everybody. This is Joe Altman broadcasting to you live from the north of Atlanta in Roswell, Georgia, where the remnants of Tropical Storm Fred came roaring through yesterday, messing up the outside of my house and my yard. And I happen to have a dog named Fred that lives here who's messing up the inside. So that's the news from Roswell, Georgia. I'm here to present to you today about Groovy and the Groovy language. I have been working with it for kind of a long time now, over 10 years. And I'd like to share about it. And I've got a partner in crime today who's helped me put this material together and figure out what to share with you today. His name's Kevin Whalen. I'd like for him to say hello to you right now.
Hi, everybody. Yes, thank you, Joe. I am Joe's lovable sidekick here for this presentation. Coming here from sunny Phoenix, Arizona, where we did just recently get some rain, but otherwise we're sitting here in the 115, 118 degrees. So keeping it warm here. So nice and toasty, but no hurricanes. But yeah, excited to share you some of my insights. We've been kind of using Groovy now with a few of our EPM implementations. A lot of power, a lot of good stuff coming through this. So I'll try to add some color commentary to Joe's words of wisdom here.
All right. I'm going to spend a little bit of extra time on this webinar, even though I've blown through all of this in the past several years. There's kind of newer news in the NRL front. If you're familiar with us, you may not be familiar that we have joined together with many other, well, not many, but a few other really well-known and well-regarded companies and formed a company called Argano. We are now Argano Interrel, a part of a larger animal that's learning to market lots of different services, including what we do in the EPM space. We are still specialized in EPM, still doing what we do best, focusing on S-based planning, analytics, dashboarding, reporting, all the great stuff that we've been doing for upwards of 20 years at Interrel. We have been multiple years winning a Partner of the Year with Oracle, a long history of success there, and I'm proud to work for this company. And we have a little bit of a new reason to be proud, actually, because we recently did a study, and everybody wants to get the word out about this in the leadership team. That our net promoter score is through the roof. So a net promoter score is basically the percentage of people who think you're rad minus the number of people who think you're pretty much not rad at all. And 77% is, well, this guy's eyes are lit up as stars. That's what happens when you're at 77%. The average in our space for general system integrators is 24%. The big GSIs, the large global system integrators, is about 9%. Everybody's unhappy with those. We retain a high net promoter score along with all of our other partners at Argano as part of the study that we did to join together and form this great company. And so what we are planning to do is keep it up around 77 and not sink down into these lower ranks like the other companies that are trying to sell multiple types of services globally. So that is us. And hopefully, if you're interested in learning more about the whole Argano story, we've got the website out there at argano.com. And you can always talk to any NRL representative who can tell you all about the exciting new times that are happening for us within our company. But we are here right now to talk about Groovy and how Groovy as a language is being used within the EPM cloud space. I was recently attending remotely to the Kscope conference, and there were several sessions in there about Groovy. Whenever I talk to the planning implementers here at NRL, or anybody else out there who's working in this space, in the EPM space, building planning applications, everybody's talking about Groovy. There's a whole lot of functionality that have been brought to the table within planning, and actually it's moved into financial consolidation and close now as well. where this language called Groovy is being used. And it's an exciting new time. Everybody is buzzing about this, and everybody's want to learn about it. So thank you for joining here, for trusting us to try and give you a little bit of information about Groovy. We're going to try and cover some basics for those of you who may be new to it, but also we're going to give lots of tips and tricks to people who've been playing with this, who've been using it, kind of know the ropes a little bit. We've got some material in here for you as well. It's pretty clear that Groovy is here to stay within the EPM space, within planning applications in particular. We're seeing it really being implemented as within business rules, within most of the applications that we're building. There's just a lot of power and ways to get things done within business rules that are done in Groovy that are just not offered with the features that existed in the application prior to Groovy being introduced. Kevin, we got some chats coming in, maybe they've got some questions. Can you monitor that while I drone on about Groovy and put these people to sleep?
There's a comment that's what we were told about MDX. So
yeah, well, actually that's not entirely inaccurate, except what we are seeing right now is Groovy is exploding on the ground in actual implementation. So we think that it will probably have a larger foothold than MDX wound up. You can still get away these days not knowing MDX very well, but anyone who wants to be a fully capable planning administrator is going to need to have some Groovy chops. So that's what we're here to figure out. How can admins get up to speed? There's a lot, like if you have seen any of the other presentations or tried to read the documentation, there's quite a lot going on here. What we've tried to do is break it down into categories and give you guidelines on how to manage your learning path, what areas are important, because the documentation oftentimes doesn't tell you what the key spots are, what to concentrate on. So we're going to try to give you some of that information as well. We are here to help, and that's what this webinar is for. You should be able, after seeing this, to know where to go to learn more and to know some of the key places to get started on building out Groovy scripts as part of your business rules, as part of your planning, and now FCC applications. So people come to sessions like this with a lot of different questions. These are some of the main ones, like what in the heck is Groovy anyway? What does it do? How does it apply to me, right? I'm an EPM admin. Why do I care? Why do I need to know? And assuming that you can convince me, I do need to know more about it. How can I go about that? So let's just get started on the first question. What is Groovy? So as you may have heard, it is a programming language. One thing that I want to be really clear about is that as a language, it is a completely separate entity from Oracle. So Oracle didn't invent this as a planning feature or something that's part of their cloud technology. They saw something that was out there in the world that was working. That's pretty cool. I mean, I really enjoy writing in this language, and I was very happy when Oracle decided to kind of enfold this really cool language into the cloud EPM space and allow you to write business rules in a different language. You always had to use the CalScript language before. Now you have another option. You can do it with the Groovy language. So what it is, it's a completely full language. It was developed many years ago in the early 2000s, I believe. And it was created by just programmers who were using Java and continued to say to one another all day long while they were writing, well, wouldn't it be groovy if we could do this? Wouldn't it be groovy if we could do that? If this language was different in different ways. And so they went off and created a language. It's really, really similar to Java. But as you'll see, it's got a lot of really cool ways that you can use it. And having written in, oh, go ahead.
No, I was gonna say one of the things though about this, it is as it's a kind of similar to Java, and a lot of people like myself coming from just pure S-based calc scripting, it is different. It's kind of it's object-oriented, so it is a little bit different in ways of, or quite a bit different in terms of syntax and ways of looking at things. It is a huge language that's all over, that's not just for this stuff, as Joe had mentioned, but there is a little bit of a learning curve on this as a different type of an architecture, but it's so much more powerful that once you start getting to use it within the EPM space, you'll start realizing like I'm even starting to forget some of my old calc scripting rules as I'm getting into Groovy more.
We've been figuring out how to do it
Yep.
the Groovy way. Kevin and I have spent a number of nights just up late on Zoom together, solving problems through Groovy. And so we both developed quite an affection for using it within the EPM space.
I'm starting to do programming at night when I'm sleeping. I'll have my eyes closed and say, oh, you know what? If I flip this over this way and make this attached to that, and then wake up and ready to
wake up in the morning with an algorithm fully formed in your head. So as I say, it's derived from Java. I did a little exercise. This is an actual thing that I did several years ago. You can take code from Java that looks like this right here. So the reason that we talk about Java so much when we're talking about Groovy is because the syntax is almost completely compatible. Like if you go out into the wild and you find a Java code example or a snippet of code, you can almost always just take that and copy it and put it into your Groovy script. So Groovy is almost a superset. There are a few differences, and that's why they have to lay it out here in their website. But this is all the Java code it takes for you to be able to read a file from your disk and print it out to your screen. And there's a lot of stuff here that's called scaffolding, and lots of stuff that has nothing to do with what you're trying to do, but just a bunch of code you have to write in order to get set up so that you can do the thing that you want to do. Groovy is a lot more about getting you directly to the action. What is it that you actually want to do? So if you're able to take this entire script here, this whole program that you've written in Java, and use different enhancements that Groovy has put on top of Java, and then write this. That what you see right there on the bottom of the screen is an entire Groovy program that does the same thing as the thing up above, and you have to have all of that stuff to do it in Java. And when I went through this exercise, when I was first learning how to use Groovy and teach other people about Groovy, I think this is a really great example of just being able to do what you want to do and not have to worry about all these extra pieces of code you have to write just to get it to run.
So we have a comment in the chat from a Python fan. Let's say
Python fan, okay.
Why are we using Python in EPM? Why not Python instead of Groovy? And I think this is going to be an Oracle decision, but
yeah, you would have to ask the planning team. I'm sure that they did a study, and when they were planning to bring in some sort of scripting language, they had to make a choice. They went with Groovy. It may have something to do with its syntax similarity to Java. Perhaps it would ease the learning curve for Java programmers to make the transition. We would have to ask the Oracle folks that specific question. Personally, I was quite pleased because I was already into Groovy at the time. So one of the things that we're taking advantage of in Groovy is the ability to use it as a scripting language. So similar to what Python can do as well. Now you can write a whole program out like this in Java or in Groovy, and this is what it would look like just to say hello world. All this extra stuff. Within Groovy, this is all you have to do. This is an entire program, so that's all you have to write, and it's done. And both of these will print hello world out to the screen. Now we are going to be writing in this scripting fashion within business rules. So you can see we're not creating classes or using this main function or figuring out what goes into that. We're just getting right down to business, defining variables and accessing cubes, substitution variables, or whatever it is that we need to do, just writing the code to do that and not worrying about having to nest it inside of classes and stuff like that. So I want to tell you a little bit about some of the key data elements that you'll be using in Groovy code. These are similar, like you may, if you've worked with programming before, you've worked with integers or strings or things like that. These things that we're about to tell you about are very essential to working with Groovy. Lists and maps. So I'll tell you first about lists. They're You may have heard them referred to as arrays in other contexts. It's simply a list of things thrown together, and you can refer to them as a unit. So I've got a shopping list over here. You can see what I'm doing within the code example is I'm defining a list of letters in the alphabet, right? So this line 1 is creating a list. It's got 3 things in it. And when you look on line 3, you can see the indexes or the indices, they begin with the number 0. So the 0 is the first one, 1 is the second one. So it's a little bit confusing, but as long as you remember, you start with 0, you should not have too much trouble. You might make a mistake sometimes and you just have to fix it by subtracting 1. You can see when I use the index 3 to access the list, I can add something on there by saying the third element is going to be a D. And this is another bit of syntax. Another way to add something onto the list is to use this double less than. It's called a left shift operator, and it's like slamming that E onto the end of it. And then you get to the end here, and you can see that we've built a list that's got all 5 of these things in it. Little pro tip: these little assert statements that you see here, these are really cool ways to make sure that what you think is happening is what's really happening within your code. You can write this out, and when you say assert and then there's something that you're going to assert, that has to be true at that moment because that is executable code, and it's going to fail with a really cool message about why it failed if that doesn't evaluate to true. So you can see within Groovy documentation, a lot of the examples that you'll see online, people will use these assert statements, and it proves out that the thing that you think is happening is really what's happening. So we're using that a lot through the code examples in here, and you can use it within your own code. Like if you need to make sure there's a certain set of conditions set up before you move to the next block of code, you can write an assert statement and write out something that's going to evaluate to true or false. And then if it gets past that part of the code, then you'll know that you've met all those conditions. So that's a really cool thing to do.
A little bit, yeah, more on that. There's also, you can do print lines as well, and you can kind of read it out in the log. And that's super helpful. Something that you can't really do in the calc scripting thing is now I could see what my list was. A lot of times I'm going to use lists in the EPM space if maybe I want a list of entities that have a certain UDA or something like that. So now I can just get a subset of everything and just pick certain things, put them into a list. I could either do an assert like this or do a print line, and I could see what I have in that list before moving on, as opposed to hoping something happens and running a calc script and then hoping that something else happens, and not sure. Now I can get really detailed into what's going on with each variable or what's happening within my code. So it's really really nice that I can start logging out just sections of the code all the time.
That's exactly right. We showed this example of print line before. As Kevin is saying, when you do a print line in your business rule that's running in Groovy within EPM, that's going to print to the log. So you can go into the jobs console and check it out. I'll show you a little bit more about that later. Another thing that you could do if you weren't doing asserts as executable code, you can do a print line and just print out whatever you need to out to the log to make sure that what I think this variable should be set to budget at this point. You can print it out and then you can look in the log and make sure that it really was, because you might have made some mistake on just setting the value of the variable. So it's going to fail later on and you might not know exactly why it's failing. So you can just put those print line statements and check.
Or we can even see, like, if it gets to a certain print line, we were doing that the other day, like, are we failing before we get to this piece, or is it happening after as I'm iterating through? And you just like, we made it here, and it could just be a print out line, and then you could see if it didn't print out. So
yep,
really helpful to have that.
So this other key fundamental data type in Groovy is called the map. So that's more of a key value, like a dictionary. You're going to have a lookup value, something that it's indexed by, and then whatever the value is. So you can kind of see this table is an example of that. And what I'm doing in the example code here is I'm creating a map. So we've got a letter of the alphabet and then some animal that begins with that letter. So I can look it up by the letter and then get back whichever animal corresponds to that. So there's a few ways that I can access and query the map. I can use this little dot notation. So I can say dot A is ant, or I can use the same square bracket notation that we saw on the earlier slide where I was accessing the list. I can do the same thing and use the square brackets to access the map and get back whatever value is stored in there under that key. If I want to add new ones, there's actually, I'm showing you 3 different ways to add new ones here. The dot notation, the square bracket notation. I can actually also use the left shifts on this as well. And you can see in the end, this is all executable code. You could take this, type it in exactly into a Groovy program. And this whole thing, this is the entire program it would run. And this is search statement, which shows that we have all of these things in the map now.
So one of the things, I'm sorry to add color commentary on the maps.
Oh yeah.
I find myself a lot of times using Groovy is really nice between if you have multiple cubes. So maybe I have some things like I have headcount in the workforce cube, or maybe I have salaries in there. And then I want to go into the financials cube, but I want that to go to GL XYZ. So what I can do is use a map like this, and then I can easily have this out and say salaries goes to this. And as I go through my cube, I can push things between cubes very easily, and the maps is kind of the way that you can recognize where things are going. The other nice thing is the way it kind of calls it out. People that aren't familiar with it and have to maintain this code later, I suggest if you look at the map, it's pretty self-explanatory. If I see salaries equals, account 1, 2, 3, 4, 5, you say, okay, well, now I know what that is. If we've changed accounts or we need to add something, it's as easy as just coming in here and fixing the code for a non-user. A non-Groovy, experienced user can come in.
It's a really good name for it. Works out for us and for this use case, because we can literally use it as a mapping between the accounts that we're seeing in a workforce app, for example, and the accounts that we need that data to go to in the other cube. So we can put the workforce account as the key, and then the value that we're looking up is the account in the other cube. So as we're processing that workforce data, we've got the account, in that cube. Just refer up to the map, pull out the account that we need to refer to in the other cube, and then that's what we're going to send the data to on the other side.
So we just got a comment here, just something from the sales planning where a lot of the scripts are Groovy. And yes, as you start going into it, you'll see more and more of the out-of-the-box functionality is becoming Groovy. And he said it's confusing to kind of go through. Really what he's printed out, I don't know if everybody can see that in the chat or not, but it's just showing it. You're actually just calling out, you're creating your variables there. You're creating a string. You're creating a list of strings for row dimensions and stuff. But yeah, it is something that if you're not used to it, it takes a little bit of, looking at it, understanding how the syntax is. It is a brand new language, and it isn't really related to S-based calc scripting. So
yep,
and more global than that. So it could be confusing and intimidating at first. That's a little bit what we're trying to do here, is try to make it a little bit less intimidating.
Yeah, I hope after this that you'll be able to look at that code and understand a little bit better what it's trying to do. I do have a little bit about this like list, angle bracket string stuff. So hopefully will equip you to read through. Really, that's going to be one of the first steps for anybody out there who's learning it, is just having enough under your belt to read through the stuff that Oracle's already providing, that's already been written in Groovy, and just try to decipher what's going on. That'll carry you a long way. And then you can start kind of copying it and stealing from it and adapting it to what you need to do.
As any language, maybe at first you learn how to read it before you can actually write it or speak it. It takes a little bit of just.
That's a good point. Even human languages, right?
And we get another question. Groovy is tough. You're sure they won't just drop it like EPMA? Again, I can't speak for Oracle. I'm not here to decide what the future is, but they've really taken this into their own coding, and they really have it kind of embedded deep into EPM. So I'd be really surprised.
I would agree. They're pretty neck deep in it right now.
They've told us several times that this Groovy is the future, and this is what they're going with.
Here's why, right? This isn't just a feature that they added because they thought it would be cool and people might use it. They needed this. to develop the frameworks for EPBCS. So the frameworks aren't going anywhere, and there were functionality that they needed to provide that calc scripts weren't doing. Like there's a lot of things that you need, and the efficiency that's provided through here, and the fact that a whole bunch of the framework code is implemented through Groovy. I don't even think there's a way out if they wanted to get out, but all of the advanced functionality that's happening is because they've got Groovy business rules running. So I think it's a valid concern. It's a valid question. My perspective is, of course, I could be proven wrong. I was proven wrong about EPMA, which is a great example that you used. They pulled the rug out from under me on that one sooner than I thought, even though they said they wouldn't. But I don't see any way that Oracle can get away from Groovy at this point. I think they're completely in bed with it. Would you agree, Kevin?
Yeah. Yeah. And again, as we're starting to see that more and more in the frameworks and their coding, you're starting to see that they're using it, and it's providing them a lot more elegant ways of doing things too, that they could have maybe done in a huge calc script, but now they can do it in half the code and a lot more efficiently.
So I want to speak for just a moment about the way that lists and maps and things get combined together and nested within one another, because you will have to deal with this within your code within EPM Cloud. So I've done a little bit of combining here, because as we know, there's more than one animal that begins with any given letter. So instead of having a single string associated with that letter of the alphabet, I now have a list of animals that begin with that letter. So when I look up in the map, when I look up the letter, I'm going to get back from that map a list, and then I can do whatever I want to with that list. So here I am setting it up, different lists of 2 animals that begin with each letter. Then when I reference it, I can use that dot notation. That gets me to the list, and then I use the square bracket notation to look into that list, and I can pull out the aardvark. Remember, there's 0 notated, so the ant is index 0 and the aardvark is index 1. I can add things into the map just as well. I'm going to add it as a list at the beginning, and then I can just stick another element onto that list with that left shift operator. And then you can see when I get down after running all that code, I have another list now as part of the map that I set up originally, the D and the 2 animals that go in there. Got a lot of dogs in my
So we've got another question. We use PBCS, not sure where we can use Groovy, and how can we do coding in PBCS? I think, was that only in PBCS plus 1?
If you're only using PBCS, you won't have access to Groovy business rules. You have to be, as Kevin mentioned, PBCS plus 1. So some other one framework in there, you'll get it, or the full EPBCS. So if you're on, I think EPM Cloud Standard doesn't have access to Groovy. PBCS doesn't have access to Groovy. EPBCS does, and EPM Cloud Enterprise does.
Yes, if you have the enterprise license.
Yep, you got to be on Enterprise. So a quick pro tip here. You'll need to spend some time getting comfortable with the concept of lists of lists. So I've got a list, and each element in that list is itself a list. So they're embedded, they're nested. There's a lot of that going on in EPM code, especially when you're creating your own grids to query the database. So it takes a bit of work to wrap your head around that, as Kevin can attest.
Yeah, you might have, like, I'm looking at a row, and I want to say here's a dimension. This is my cost center dimension. That's going to be a list. Maybe I have a list of dimensions for a POV, right? It might be cost center, plan element, blah, blah, blah. That's a list of items. And then maybe each one of those, I want to say which members are in that. So maybe I have, cost center 2614, 2673, descendants of that. Now I'm making a list of lists. So it's just kind of a concept that he's kind of talking about that nested structure and what they're looking for. You'll see that a lot in the EPM when
we're
building
hoping to
grids.
provide you with enough tools to play with that idea and get comfortable with it. There's some other things that you're going to see frequently in EPM code, which is they're called iterators. So different ways that you can interact with those items that we were talking about that are called collections. You're going to see this function called each quite a lot inside of code. And that's what you're using to loop through one of these arrays or one of these maps and look at each of the elements that are in there one by one by one. So you can see here, I've got a really simple list that I've created. It's just the numbers 1, 2, 3. And when I run the dot each on that collection, I'm going to go through and I'm going to do a print line one at a time on each one of those. I'm just going to multiply it by 2. So you can see the first print line gets me 1 times 2, which is 2, and then I get 4, and then I get 6. This little variable name called it just happens automatically. So when I'm going to loop, if I haven't told the system what I want to call it, it's just going to call it. So the first time through it equals 1, the next time through it equals 2, third time through it equals 3. You can see here, I can go ahead and give it a name inside of this each. So it's not called it anymore. I've told it first I've got a nested list. So I've got a list of lists right here. And then when I loop through the nested list, I'm going to have each one of the items is going to be an inner list. So I'm going to be working on a list, and then I'm going to do an each on that. So I've got nested eaches. And you can see here as I walk through, I'm first going to walk through and do this list one at a time, 1 and 2. Then I'm going to do the next list, and I'm going to get A and B. So I'm just running this print line ultimately 4 times. 2 when I iterate on this list, and then 2 more when I iterate on that list. So I do recommend doing this extra bit and providing names for your variables if you get more than 1 deep on any of your loops. And sometimes you're just going to want to use it anyway, even if there's only one simple loop that you're doing here, you'll go ahead and give it a name just to be really clear about what's going on.
One of the things that I would do with the iterator too is maybe I'm going through and I've created a grid in, say, the workforce cube, and I have all the different accounts that I want to use, but now I want to map those, and that map what we talked about before, I'll go through in each one and change the header now from the workforce planning header account name to the financials account name. And it goes through each one of those, and it'll change the header as it iterates through that whole list of accounts, or through that whole map, just the list.
Right. So the person can have saved their planning form, and then you can do an each on all of the rows and pull out the accounts that are on that form, or just have an entire list of accounts that you have hard coded, and then you can do an each on that and do whatever you need to with that as well.
Looks like we got a couple more questions here. Does SBase 21C use Groovy or SBase scripting language? And is the scripting language going away? I don't think you can ever get away from the script.
The CalScript language will not go away. They will continue to enhance that. SBase 21C still uses the CalScript language quite extensively. I've heard stories of Groovy being rolled in there. I don't think it's in general release yet, but I've heard there's some possibilities to be able to write functions and expressions in Groovy and have those called by SBase, but I don't have any details about that
and
at all.
Sometimes what we'll do is take just basically the SBase script, and you can actually embed that into Groovy, put a Groovy wrapper around it. So now I can have a dynamic, like if I want my fixed statements, and I want to be able to have that dynamically calculated, because something else Groovy will figure out what that list is of things with the UDA, and I can iterate through and then actually have the CalScript language embedded into the Groovy. So you kind of can use them both. I also got, is there any process runtime improvements when writing and maintaining the code in Groovy as opposed to traditional ways?
I'll try to get to that later. There's Calc Manager is still Calc Manager, and you still write and save your rules inside of there. So there's not a lot of version control. You're just writing a different type of code in that business rule. for Andrew, what tool is used to run the Groovy test scripts. I'm going to be showing you that in a bit, because if you've run Calc Manager, you'll know that these screenshots are not from Calc Manager. I'll show you what I'm doing here, and it's a really important tip for you that we're going to be giving you on how to write and explore and play with Groovy. So wait for that. That's coming up. Okay, this was just to talk to you about a few other things that you can do. We covered the each, but you can also do a few other things that are really common and really useful in your code. I'm using a little bit of different functions on this this list that I'm creating. So I'll create a list of the elements 1, 2, and 3, and 4, and then if I do a dot find on that, that's just going to go and loop through that. And if it finds something that meets that condition, then it's going to just give it back to me. So you can see here when I do a find, this is just asking for an even number. It kind of tells you about that down here. The first even number that it finds, it returns that. If I do a find all, then it's not going to stop at the first one. It's just going to go through the whole thing, run that bit of code on every one of them, and every one of them that meets that condition as true, it'll return that. So here I found 2 and 4 as even numbers. And then there's this dot collect, which is what I'm going to use to turn one list into another list that's very similar, but I want to do some sort of transformation on it. So I do this dot collect, and in this case, I'm going to loop through, multiply every number by 2, and then that's what its corresponding element is in the new list. So when I do this collect of everything times 2, you can just see it's every one of these is 2 times the one before. And this is really useful when I got a list inside of my Groovy code in EPM. Like I might have a list of objects and they all represent members, but all I really want is the name of each one of those. So I can do this dot collect and just retrieve the name from each one of those and very easily build a whole new list. That's not built of these complex objects, but just a straight list of strings. That's those member names. Here's a few other examples of other cool things that you can do. You can find out if anything in that list matches my criteria. It'll just say yes or no. This, true, one of them's even. Is every one of them in that list? Does it match my condition? Is every one of those numbers even? No. So I get a false back. It doesn't match. I can go and find things inside of there. I find the first even one. I find I can sum them up. I can get the min. I can get the max. I can get the average. All those are just little dot functions that I can call on those lists. So a lot of cool things that you can do. You'll see find and find all and collect frequently in Groovy code. These other ones are a little bit more rare, but they're good examples. Keep you from having to write your own code to do the same thing. If you know that they're in there, you can just go and grab it. I want to dive a little bit down into the tech right now. Just for those of you that come from a programming background and they want to dig a little bit deeper into what's going on here. What we're doing is we're writing something called a closure. And that's that little guy that you see there inside of the curly brackets. I'm just going to circle it for you. That's a little data and code at the same time. So that little piece of code that's inside those curly brackets gets wrapped up and it gets passed off to the each function and it gets run over and over and over again. So we're looking at this data as code concept that didn't exist in Java at all. But because of the popularity of this in Groovy and the things that it allows you to do, it finally got rolled into Java in version 8. It's called lambdas. They work a little bit differently, but it's basically the same concept. This is something, it may help you conceive what's going on as you're writing your code. Just think of this as a little executable piece of data that you can send off, and then each function is going to run it for you over and over and over again as much as it needs to get through your entire list.
And one of the notes, as you start embedding more and more, and these are all kind of little snippets of code, like he said, the way he had it, if you go back a little bit, the indentation gets important because if you miss a closure, it's going to break. So you could have a million lines of codes, you miss one little curly boy and you're kind of done 4. So it's, and when you start getting pieces inside of other pieces and going through nested iterations, having these indentations and the way he's kind of done the syntax where he has like that line 4 is now at the same level as line 2. If he put something else in there, he may have indented it. And that makes the reading and debugging a lot quicker, because when you start figuring out, wait, where is this? It's like the fix and the end fix. If you can't figure out where that end fix was, or am I on the right end fix? It's similar.
That's right.
So these indentations are nice. The way he's
that's a good analogy. Fixes, lining up your fixes and then fixes. Yeah, I would recommend you to be very vigilant about your indentation. This is typically the way people write it. They'll put the open curly bracket on the same line as the call here, and then they'll line up the closing curly bracket on the same line as where they got started. So be really careful about that, because it's easy to get them out of line, and then you're confused and you can't even get your closed brackets to match your open brackets. So let's get a
question. I don't know about Python, which is for space indentation, but I don't think the indentation does anything to the code. It's just for readability.
Correct. So yes, in Python, that indentation means something. In Groovy, it does not. So you can mess yourself up in ways that you might not notice by indenting wrong, and you just might look like it does one thing when it's really doing something else. So be really careful about how you indent and how you line up your curly braces. So let's talk about how this actually works on the ground within EPM Cloud. There's a few things that you can do, and it's going to be falling in a few different ways that you can use Groovy to get things done within the EPM space. Now, one of them is just creating count scripts on the fly. So instead of having a script that's written, and maybe I can substitute in a few variables, like that's all I can do here. That you see on the left side, I can grab some runtime prompts or substitution variables or something and get them into a script. But what I can't do is something like over here on the left, where I would rather not fix on all of the cost centers, but they're on the rows on my form or on my grid. And I want to be able to pull them out off of the rows. They're defined as at level from all cost centers, but then I've got suppression on, so most of them don't show up. How do I do that in a count script? I really can't do that on a count script that's attached to a form and react to it as if suppression were on. So there's some stuff that I just can't do. So what I want to be able to do is use Groovy to manipulate with strings and make it spit out a calc script, which will then run. So I can be a lot more efficient about what I'm doing with my calc scripts. Over here on the left, I'm grabbing the cost centers off the form that actually showed up on the form because I had suppression on, and I'm using them and throwing them together into a fix statement. So I'm only fixing on the cost centers that were on the form. Over here on the right-hand side, doing a similar thing, but my fixes are on something else. I'm still grabbing all the cost centers that were on the form, but I'm looping through them and I'm outputting a little piece of code only related to the ones that exist. So you can see here, I only had 3 cost centers, and so I kicked out one line of code for each one of those. You can imagine if that form had 1,000 potential, right? There's 1,000 level 0 members, but only a few of them actually have data, and everything else got suppressed out. I'm much better off using Groovy to iterate through and find out what's really there and spit out code that's only relevant to what's there. And I do this sometimes, like I'll throw together for a data clear. I can just use a calc script, right? And do a clear block all. And then I use what's on the form to drive all of the fixes on all of the different dimensions. And then do a clear block all that's extremely focused, and it clears out all the data. And I'm using Groovy to create that calc script on the fly. I can use a header, just kind of hard code the header and hard code all the end fixes. And then all the fixes themselves are based on, all the fixes are based on information I'm getting from the form in real time. So as I say, this is really great for when you have suppression on a form.
And we've seen huge performance boosts, like something if there was no other way to do it, but basically do every single cost center for every single currency for every single, and you get huge things. You don't really need all that, but you really can't get away from it in the scripting if you can make it just dynamic and work on the thing. We've seen scripts go from hours to instant to seconds.
Another thing that you can do is like people have generated really long count scripts before, and they've kind of used code to generate that, and then that's the hard-coded count script. You could just have the code that spins it out, that loops on all the different things, and spits out identical code over and over again with slight differences. You could just have the code in here, so you're not maintaining a giant count script. You're maintaining the thing that creates the giant count script. These are three different tools that you can use to do string manipulations to build up these count scripts that you can then return to the engine to run on your behalf. String builders are used like this. Triple quotes allow you to take one string that you're creating and just lay it across multiple lines. And then there's this G string functionality. Don't blame me. I didn't name it that, but it's called a G string. And it's a really nice way to do little substitutions. That's what this dollar square curly bracket thing is doing right here. Substituting in something in the middle of a double quoted string, make it kind of easy to lay that out. You can put these little placeholders in and substitute in values when that thing runs. One of the things that you'll be doing even more often than generating count script is going to be directly interacting with grids, whether it be the form that the user has saved like this, or whether you're generating your own, and you can create them in the background, retrieve data or send data as well, using the API that they've built for Groovy. So the simplest thing that you'll do is just do a run on save, and then you'll have access to the grid that the form defines. So we can see all of this data, we can see all the rows, POV, and everything. And you can use this information to fix on only what you need to. You can even, as we'll see in a second, focus on only the pieces of data that have changed. So the cells that are yellow now because the user made some sort of change, we can laser focus only on the data that has changed, and then respond only to those intersections, so that we're not having to deal with a bunch of stuff where they've just saved the same number back into the database. You can get really smart with what you're doing as you're walking through here. You can look at the data, you can validate it, you can test it for whether it meets certain criteria. You can compare it to data from some other place in the database. You can multiply it by a driver that's not even on the form. A lot of cool stuff that you can do, but the simplest thing is just to process the grid coming off of the form itself. This is what the code looks like when you're only looking for changed data cells. So you get that grid, so that's referring to the entire thing. And then I can do this little cell iterator thing and ask it to give me back only the cells that have been edited. And then I'm going to walk through those cells that have been edited. I'm doing something very simple here, and I'm just outputting their data into the log. So I can see here, I've grabbed all these changed cells and nothing else. So this can be a very powerful way to write efficient code and ignore everything that the user ignored, right? Let's see. This is a really important thing, and I'm going to show you how to use this in a second. There's two different ways that I can build a grid through code. And there's no real user interface, or you never see it. It's happening back there. But I can use this data grid definition and put together, through code that looks something like this, I can put together a grid that works very similar to a planning form, defining it the same way, my POV and my page. And when I'm defining my rows and columns, I can use functions like this. You can see right here, I level 0 descendants of this dimension or this member. Like that's exactly the same syntax that you're using when you're building a planning form. So when you're using this data grid definition, like when you need to build something that's using these metadata functions, you can use all the same ones that you're using when you build a planning form. And then that thing that gets built back there for you, you can visualize it exactly as you do a planning form. You can turn suppression on and all that stuff too as well when you build it. Now, the other way to build it is not the data grid definition, but just a data grid. I'm not a huge fan of the way these things are named, but that's why I'm going to try to tell you how they work. This one works a lot like SmartView. So you can imagine this just as within your Excel, and you've very clearly laid out in every single cell what member that's going to be in there. And then you can do that retrieve and pull the data in, or you can put data into it and save it back. So it's working exactly like SmartView on both sides, retrieval and saves. And one thing that's really cool about using this data grid to lay out data that you want to save to the database is it will create a block every time. You're not going to run into block creation issues that confuse a lot of folks when they're trying to deal with the calc scripts and why isn't it working, and it turns out to be a block creation issue. If you're using Essbase from back in the day or SmartView, and you need to create a block, what would you do? You'd put some data in SmartView and you'd save it. This is doing the exact same thing. You're populating that grid and you're saving it. You're guaranteed that you're going to get block creation. When you figure out what data you need in the database, put it in the grid and save it.
So a couple of, actually back on that one second, there's a couple of quick things I know. If you see like add the POV where you get years, so those are the names of your dimensions. And then if you see FY16 current, and those are again lists of lists, you can tell by the brackets as you mentioned before. But this is something somebody not has any idea, and I have to maintain this. Well, I could see years equals FY16. So if I need to change it to FY17, I don't need to really know Groovy. It's easy enough and clear enough that I can kind of at least understand if I know my dimensions and I know my members that I'm looking for, I can actually change that, like change bank balance to January or something like that. And I can see that it's lined up with the period. So there is a bit of intuitiveness that makes it somewhat, for somebody that's completely scared of this whole kind of thing, there's certain parts of code that you can just be like these blocks of codes I've given to other people that haven't used Groovy at all. And they know what their dimensions are, and they know what members they're looking for. And now it's just a grid, a POV, a column, and a row. So as much as things get intimidating on parts of it, there's pieces of it that you can just intuitively change. And now I could get moving on with this without knowing any Groovy.
Yeah.
And customize it for my application.
Like this call here that does add POV, this is a list of the dimensions, but when we get into telling what the members are within those dimensions, we've got an extra layer of square brackets. So this is a list of lists. Same thing for the add column. This is a list of dimensions, and this is a list of the elements within each one of those dimensions. So yeah, thanks for bringing that up, Kim. This is a really neat thing that we've been doing here over the last few months at Argano NRL to create really cool functionality within planning. Kevin and I actually worked on this on a real client, and we've got within Excel, we've kind of mocked up what we want to happen in the calc scripts, and we've got an FX table, and we've got upper level numbers that we need to allocate, and we've got the level 0 numbers that we need to use to get the percentages so that we can allocate, and they're all kind of in these SmartView grids. And then we've got the grid that it has the data on it. That's the results that we would want to send back, we query to make sure that the calc actually happened right. So within Groovy, we basically mirrored that whole Excel setup. Use the form right as the thing that's giving us the data that the user has saved. But then we can use Groovy to open up a grid that's got our drivers on there. In this case, we're going to use headcount as a driver. It's not on the form, so we just go get it in a different grid. We can pull that upper level data to find out what the number is that we need to allocate downward. This is giving us the level 0 data for the percentages. We can pull an exchange rate table just in as a grid. All we need to know is what the intersections are, fill it out exactly like we would in SmartView, pull that into memory, coordinate all of that data across 4 different grids, just like we got 4 different Excel tabs here. Coordinate all that to figure out what the numbers should be to go into the database. And then we populate.
Those grids don't have to be in the same cube either. These grids could be pulled from any. You define the grid that you want, the cube you want. So I could be pulling stuff from workforce or capital or financials and grab all these data in one place. Yeah.
So, exactly right. So we coordinate all of those grids across all those cubes, figure out what the data needs to be, lay that data out in a SmartView type grid, and save it back into the database. And then since we've done all the math over here, it's really easy to test. We just go to the tab and retrieve it and see if the numbers are what we've already calculated and what we were expecting to see. So it's really cool. I mean, once you get it working, you know it because you know what numbers you're looking for, and then you do that retrieve and it is the numbers that you were expecting, and you're like, oh, right, this is working. So this is we've done this several times over the last, I'd say 3 or 4 months with different clients as we're figuring out new ways to use the language and use it the business rules. So it's really, really neat. Let me tell you about REST API. So this is a way that I can kind of use the web and make calls out to HTTP addresses and make things happen in different places out there on the web. So generally speaking, this is a technology that's applied all over the place. Like all the cloud products are using the REST API. I can't get into the technical details here because we just don't have the bandwidth to do that here. But I can tell you that the REST API for EPM Cloud is very well documented. You can go in there and figure out what to do with REST. If you study with REST a little bit, you'll be able to access EPM Cloud's REST. The way you do that from within business rules is a little bit tougher to figure out, but with just general REST documentation out there that's in the world and those tools that are out there, as well as Postman and stuff like that, and the documentation for the REST API, this is within reach. A quick tip, like anything that you're doing with EPM Automate, that's doing REST anyway. So everything you can do with EPM Automate, you can do with REST, you can do from inside of a business rule, except refresh. You can't do a refresh because you can't refresh while a business rule is running, and your business rule, if it's asked for the refresh, it's going to sit there. It's still running, so the refresh will fail. Everything else, I think you can do because it's just
using REST to allow users to run data maps that they wouldn't be able to use, if it's an administrator only, but you can kind of use the REST API to get around some of that.
That's right.
You have a specific user that doesn't have access to run a data map, you can use it.
So users can run smart pushes, which are derived from the data map, but they can't run the entire data map. If you use a REST API,
yes, you
can have the Groovy run that data map as admin through REST. Yep, good point. So this is something that we've been doing as well. I've been helping someone do it just here recently, and we've done it in the past. You can actually take data from one pod and send off calls through the REST to data management to move data from pod to pod. So here we've got data moving from planning over into profitability module for allocation. Then I can launch that allocation rule over there, and then I can make another call to pull the data back into planning, and then I can roll it up too within that rule. So within one go, a user hits save, I can do all the calcs I need on the planning side, send it to PCM for allocation, and then bring it back. And there's a question if they need to be on the same domain. The answer is no, they do not have to be on the same domain. I can do REST API to pods outside into other domains. And I can do REST APIs to virtually anything. Salesforce has REST API, NetSuite has REST API, Workday has REST API, right? I can interact with anything. I've got a lot of different ideas. I can use REST API to send messages to collaboration suite like Slack, and I can post into a channel that the nightly backup finished successfully or whatever. There's a lot of cool things that I can do. I can tweet if I want. So there's a world of ideas that are out there that we're just beginning to tap into for using the REST API to all kinds of web resources out there outside of planning, outside of EPM Cloud at all. So I know that we've gone over a little bit. We've only got a few minutes left in the presentation, but I want to tell you how to get started on this stuff if you need to know how to learn Groovy. So if you have a few more minutes, please hang out with us. We're going to go through this as quickly as we can. We had a question about this earlier. You're going to be better off trying to learn Groovy if you install it as a standalone thing on your own computer. And don't try to learn it just isolated out there in the EPM Cloud. There's a lot of extra stuff out there that goes into learning how that works. If you install it locally, you can run pure Groovy stuff and just find out what's happening locally. First, you're going to have to install a Java development kit that you can download from Oracle, install that, and then you run this little command here in a command line window to make sure that it installed properly. So if you get this back, then you can go and install Groovy. So that comes from the owners out there at Apache. You can typically just use this link here, and it does all the installation that you want. You can just install everything. That's not very big. And then you do Groovy. You do this little command here. This has got 2 dashes. The other one only had 1. But if you get this back, then your Groovy is working. And the way that you do little experiments is you can run the Groovy console right off your start menu. You can write something like this. I'm just experimenting, right? I'm trying to figure out how to combine 2 lists. I'm not exactly sure what the syntax would be. So I can just try stuff out here and do a couple of things and then get the results here. And then it's really easy. You can just run it, and you can just run it and rewrite it and run it and rewrite it. And it's really fast. Kind of compile and test mode there. So these are where most of these screenshots have been coming from in this presentation, just code that I was writing on my own computer in the Groovy console. You can roll it into other, like if you're a programmer, you can roll it into, I don't know, Eclipse or add a jet idea, right? Those sorts of things. That's a little bit more involved, but this is a really good way to just try out and play with Groovy and run things that you're finding on the web or just trying to explore the language features. That's a separate endeavor. To learn the language, you just want to use general tools out there. There's books, there's blogs, there's actually someone who's been writing, Kyle Goodfriend in Hyperion has done like 50 different entries on his blog about how to use Groovy. And it's from an EPM perspective, so that's really great too. This is for learning about the language. If you want to learn about the API itself, you got to go to that Oracle documentation. So you can find this within the cloud documentation. It will link you to this here. That's called the Java docs. I want you to know that there are examples, but you have to know where they are. You have to go right here, and you can find this little big word link that says here. And when you go to there, there's some examples that you can use, and it shows you different ways to do things. I think kind of outdated right now. Some of them are like adding members to the outline, and what people really want to do is access grids and stuff like that. But good examples that you can leverage. There are also examples embedded down inside the Java docs. Speaking of which, navigating the Java docs is a skill that you will need to develop if you don't have that already. There's a wealth of information waiting in there, but it's a skill to go and learn how to find it. There's a couple of ways that I want to give you a head start on that. There's this index tab that you can go to, and if you're trying to figure out, I need to get the member name of something, you can just go in here and try to do a keyword. Just do a Control F in your browser and go and do keyword searches, and maybe you can find the method calls or the objects that you're going to need to use to do this operation that you want to do. You can also kind of do it the other way around. If you have a guess as to what object might have the code in it, what you want, you can go to it in the little class list here. And like if I think I needed to do a get density because I wanted to know if this dimension is sparse or dense, I could go to the dimension class and then read up on that. But you'll gradually get a feel for how the Java docs work and how to navigate it and find what you're looking for.
Once you first see this, it's really kind of, you're like, what's all this mess? If you go back real quick, just to show
Sure.
that add, you see add column, list string, list string, you're like, that doesn't mean anything. That actually does mean something, and you will use that because you want a list of strings, which is the name of the members, and then a list of strings. And so that's going to be like the header and the data. So knowing what that means is a lot of errors. You start fighting around, what do I need? Do I need brackets or not? It's kind of right in there, but it might be tough to understand what you're looking at the first time.
Yeah, there's a couple of things that you'll learn from the Java docs. It's like, what is the method asking me to provide it? So like as Kevin was pointing out, it's going to want 2 lists. And the first list is a list of strings. The second
That's your
list
dimensions.
is a list of strings. Within the dimension, I'm gonna, oh yeah.
I want the dimension name, and then the second list of string is going to be the members inside that dimension as set up as list of lists.
So it will kind of tell you,
strings.
It will tell you what to pass to that if you can read this part.
But the first time you look at that, I looked at it and said, well, this doesn't tell me anything. I don't know what's going on.
Yep, a little practice. Those are called generics. I've got a slide about those in a second. So yeah, it will tell you two things, like what it's asking for, and then it also will tell you what you get back. So if I follow these links and I go and read up on it, you can see here, like this returns an integer, and this returns an integer, and this returns an attribute dimension object. So you can go and learn from the Java docs what you're going to get back if you call that function. So here's a few things that we wanted to, like, there's no space like for them to logically go, but things that you need to know. When you write a Groovy script in a business rule, throw this little magic comment line up top. If you're going to be using runtime prompts, just refer to them inside of curly braces up here in the first line, and these will be the names of the runtime prompts that you're going to use. This one, even if you're not using runtime prompts, put this sort of blank one up there. As I say, it's kind of a magic comment. You want it to be on line 1 of your script, and Oracle just sort of built this in so you can use it to get runtime prompts if you need them. If you don't need them, go ahead and have it up there and have it be empty, because it just it will mess up your code later on, and you'll thank me at some point for this tip. When things act very confusingly, and then you remember to do this and things are working again. So just always have that as the first line, and you'll save yourself some headaches. The second, as Kevin alluded to before, use the print line a lot. Just print like every step of the way, because when you get over if this thing fails somewhere along the way, all of the log entries will have been made up to that point. So you can see here, I'm walking through, I'm logging where I start. I'm logging like some of the variables, like I want to make sure that they're the right thing. As I'm looping through, I'm making sure that I'm processing the right thing. And then I'm just kind of, oh, I finished. So if I get all the way to the end, that means that the whole thing ran. This is coming out of the job console. You'll want to make a habit of running the thing, having lots of log messages. This is while you're building and trying to figure out how to make it work. Then you go over the job console, refresh, open up the thing you just ran, and read the log out of right next to the status where it tells you what happened. This is a thing for me, just as you become a Groovy programmer, there's two things that you need to do. You need to figure out what to work on, and then you need to figure out what the work is that you need to do. This thing on the left is mixing those two things up. What I want to do is try to avoid this if statement inside of my loop. If I can narrow down what I'm looping on first and then loop on what's left, that's what I want to do. So instead of looping on this whole thing and doing an if statement, if it is even, then do the thing, I'm going to narrow it down to only the even numbers in the first place. And then I'm going to loop on just that list of even numbers. So it seems like a small thing right now, but as you get into writing more complex Groovy, you'll want to be thinking about a separation of duties. Try to narrow down your data set in one way, and then do your looping or whatever you need to do, and write that data that actually does or write the code that does the processing as a separate entity. Sometimes you can't keep them completely clean, but a lot of times you can. And lastly, I want to talk to you about the static type check, because this one will cause you problems. There's a few ways to deal with it, but Oracle turned on a flag inside of their Groovy compiler where it's going to be really, really serious about being confident when you compile the code that it's going to run, that all the types of all the different variables are going to match up. And when I go and call a function on that object, it's going to be there. It's not going to be the wrong kind of object. So they have this static type checker turned on. And sometimes you'll get these messages back where it doesn't understand what this method is, or it doesn't exist, or can't call this on that kind of object, that sort of thing. And you'll need to be really more explicit about what you're doing to satisfy the static type checker. Now, one thing that you can do is just be really, really explicit about what your variables are from the beginning. So def is a completely generic one. It's just define this variable, and it can be anything. Sometimes the static type checker can figure it out from the way you're using it, what it's going to be when it gets to a certain point, so it won't mind that much that you're using def. But if you want to just from the get-go be really clear, like this one's going to be a data cell, and this one's going to be a member, and this one's going to be a dimension, and this one's going to be a grid, you can be very explicit, and a lot of example code is pretty explicit about it. Personally, I don't do it that way because I cut my teeth on the other way of writing Groovy, where most of you use defs and you don't care. I get more specific when the static type checker forces me to. Some other people choose to be super explicit from the get-go. Another way to deal with it is to do this casting thing. So you can, at a certain time where if it's barfing on a particular line of code and it says it doesn't know how to do this, you can just kind of coerce objects from, or prove to the compiler that at this point it's going to be a float, or it's going to be a data cell, or whatever it may be. So you can use casting, so you can read up on that. There's two different ways to do that. And the other is the generics that we talked about before. So when you're defining a list, it's not just a list. You can say it's a list of strings. You can say it's a map that has a string for a key and an integer for a value, that sort of thing. And you can see within the Java docs that they use that syntax a lot. And sometimes you need to adapt and use that within your declarations of lists and maps, just to convince the static type checker that it's going to be okay. This is really a techie topic, and I would really love to ignore it completely and not have to tell you about it. But this is probably the biggest pain about writing Groovy code in business rules. Is once you get to a certain point and you can't get it to compile, and you've got to figure out why the static type checker is giving you grief. So unfortunately, it's a bit of a down note to end on. But there is a way through, and you can just look into these three different ways to kind of deal with that issue. And we have not run into one yet that we haven't figured out, but sometimes it's a bit of a challenge. So on that note, I'm going to give you a little bit more of an up note about things that we do have coming up.
Thank you, Joe. And I would love to share this exciting news with you all. Registration is now open for CaseGo. Join us in person this summer in Grapevine, Texas for this highly anticipated event. As a gift to you, save $100 on registration by using the exclusive code ARGUNOINTERREL at checkout. And I'm going to pass it back off to Joe and Kevin. Do you have any final thoughts that you would like to share with everyone?
To throw this up so they could screenshot it. And we did have some questions about analysis and libraries and stuff like that. I'll note that Groovy probably has those libraries generally available because you can use any Java library in the world, basically. But what you have access to from within a business rule is pretty restricted.
Yeah, Oracle's very, because of the security, it's very kind of, things are whitelisted, and there's not a
lot of things.
Not a free for all, right? They try to
basically
make sure that you
working
can't get a back door and accidentally.
Yeah, I think working with
people
you can do, and the HTTP connections are whitelisted, but most of the rest of the Java libraries are not. So dashboarding and all that stuff, definitely possible in Groovy as a whole, as a language that you could do on your local PC. You're not going to be able to do any of that, at least at present, on the cloud, in the EPM cloud environment within a business rule. It's just not, we don't have the hooks to do it. Okay, I think that's everything. Thanks everybody for tuning in. It was a lot of material and we get a little bit long. So those of you that could stay, thank you very much for your extra time, and I hope it was worth it. And with that, on behalf of ArgoInterRel, our helpful assistant Brianna, Kevin Whalen, and myself, Joe Altman, thank you for tuning in, and we'll see you next time.
Thanks, everybody.
Thanks, bye.